talk, because we've all kind of seen trig functions before. It's nothing fancy, guys. All right. So remember when we started doing trigonometry, when we were still learning about the SOHCAHTOAs, the SOHCAHTOA, we learned that if we are given a point on a Cartesian plane, we can connect this Cartesian plane to the origin of our circle, okay? And we know that the distance from here to there is called the radius. We call it r, right? We also know we call it r because this point can make a circle all the way around our Cartesian plane. That's why we call it r, because if this is a radius is connected to a circle that goes all the way around our Cartesian plane. Then we know that from this point over here, we can draw a straight line that makes a 90-degree angle with our x-axis. And this is our x value. This is how far x is from that point. And this is our y value. And that's how far that point is from the x-axis, or from the x-axis over there. So we know that SOHCAHTOA can also be written as S is y over r, cos is x over r, and tan is y over x. All right, give me a thumbs up if you've seen this before, because this is basic trigonometry that we should have all learned by now. Yes, we should have started trigonometry. We should all at least know this. Okay, if you do not know this, it comes from the idea of SOHCAHTOA, because this is our angle theta over here. And we know that if we have a right-angled triangle and we have this angle over here, theta is just the same as opposite over hypotenuse. Like there we've got sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. SOHCAHTOA. But instead of saying SOHCAHTOA now, we are going to be using y and r, and x and r, and t, y and x. Now, Gia, it's not as complicated as it looks. This is all that we have. We have a triangle on the Cartesian plane. This side is the opposite side. This side over here is the adjacent side. And this side named r is the hypotenuse. That's the only difference. Okay. That's the only difference. Instead of calling it O for opposite, we're going to call it Y. Instead of calling it A for adjacent, we call it X. And instead of calling it H for hypotenuse, we call it R. Okay. Nkechi says, ma'am, you're honestly not making any sense. Okay, where did I lose you? Where did I lose you? Because remember, Nkechi, this is a triangle. You see my triangle. There it is, with a right-angled triangle there. Okay, I'm not in this section because we're only going to be looking at the graphs. Okay, things like cosec and sec graphs, those only happen in university. We're not going to be talking about those. Okay, Nkechi, you need to tell me where it is that I've lost you. Okay, because what I've done is I've taken SOHCAHTOA and I've put it on a Cartesian plane. Yes, Didi, that's it. It's y because it is parallel to the y-axis. I couldn't have put it better myself. Okay, good. So that's it. Well, yo, Didi, don't take my job. Don't steal my job. I'm watching you. Hi, Kama.
Hi, ma'am.
Hi, my sweetie. What's up?
So, like, I just realized it wasn't trig functions. It was proving identity and proving square identities. My mistake.
Oh,
But
okay.
I'll do that as well, like later in the week.
That is like advanced trig, and they don't really ask it in grade 10, but I'm happy to do like a quick 5-minute snippet of it.
Ma'am,
okay.
they asked it here. It's gonna be in that exam. I'm panicking because like now I'm
okay,
looking at
it's fine. It's okay, my sweetie. I'm gonna show you. It's not that deep, I promise. Okay. It's not. I will show you. Don't stress, my sweetie, don't stress. Okay, and this, it also makes up part of what we're doing here, just in a different way, Kama, don't stress. Okay. Unat is like side eye, bombastic side eye. All right, we're going to get to that. Now, guys, now what's happened is we are going to look at these three graphs, right? And we're going to call these three graphs our mother graphs. Okay, mother graphs. Okay, Akona says, ma'am, please explain the R. The R is the hypotenuse. Okay, Akona, R is the hypotenuse. Okay, sure, princess, you've got 5 seconds. Yes, the mother graph. Okay. That's it, princess, that's enough time. All right, let's go. All right, so we've got 3 different identities, guys. We know this. We've got sine, cos, and tan. Right. Now, I want everybody to pick up their calculator for me. Okay, everybody got a calculator? Pick up your calculator and type into your calculator sine of 0. Sine of 0. Okay, I'm going to do this. I'm going to call this the y-axis, and I'm going to call this the x-axis. All right. Anuchita says it's 0. Does everybody agree? Sine of 0 is 0. Okay, so I'm going to go onto this new y-axis that I've drawn over here, and I'm going to put a point 0 like that. There's my origin at 0. Then I'm going to split my x-axis into 360 degrees. So guys, what I've done is I've taken this top graph, and instead of counting 360 degrees going around in a circle, I'm going to make my 360 degrees a straight line. Okay, so I'm going to split it up into 90 degrees there. Yes, they are. Can you see that they are? 90 degrees, 180 degrees, 270 degrees, and the last one over here, 360 degrees. All right. So on this axis over here, I'm going to put 1, 2, 3, and down here, -1, -2. All right. So we all said that sine of 0 is 0. Now punch into your calculator sine of 90 degrees. Sine of 90 degrees, guys. Tell me what sine of 90 degrees is. It's 1. Good. So on my x-axis, I'm going to go to 90 degrees. And on my y-axis, I'm going to go to 1. And I'm going to see where they meet. I'm going to go there. That's where they meet. Good. They meet at 1. Good. What is my next number that I'm going to ask you guys to punch into your calculator? I'm going to ask you to punch sine of 180. Good. Halalelo. Type in sine of 180, and what do we get? What do we get? Good. We get 0. We get 0. So we're going to be down here. Right. Okay, guys, I just want to do something very quickly. I just want to move my 1 to up here. Okay. I just want to move it to up here just so we get a better idea of what the graph is supposed to look like. So 90 and 1 actually meet over there. Right. Good. So I'm also going to have to move -1 now. Ish. Okay, -1. Good. The next step, guys, is to punch in sine of 270. What does sine of 270 give us? Good. It gives us -1. So it's going to be down here. There it is, -1. And then the last dude, sine of 360. Kama's cheating. She's already got the answers put in. 0. There we go. 0. Right. Excellent. I don't know where you got the -0, but it's still 0. All right. So what we've now done, guys, is we have drawn the mother graph of sine. Okay. The mother graph of sine is the simplest graph that we get of sine. Okay, the mother graph is the simplest graph of sine. This is the mother graph of sine. Yes, Kama.
Oh, I'm so sorry. I thought like I put my hand down. I was just going to ask if we're like doing the sine graph. Like I saw from the first coordinate and then the 270 to minus 1.
Mm-hmm.
Like I noticed that
Good.
the domain and range just seemed to match the thingy, the sine graph. I just forgot to raise my hand down the minute you said it.
We're starting with the sine graph and then we'll move on from there. Okay.
Sure. Thank you so
All
much.
right. All right. It's making a lot of sense. I'm glad. Okay. So Princess, when you say you're lost, my sweetie, where did I lose you? I need to come and find you. Okay. Teacher Nels, where am I going back to? Buseletso, where am I going back to? Okay, Sinobutle, mother graph basically means the simplest graph. Okay, the simplest graph. Okay. Oh, Puseleto, don't worry about copying down the tan graph because we're going to draw it ourselves. Okay, we're going to draw it ourselves. So don't stress. Okay. Palesa, if you say that I've lost you, ask me, where have I lost you? Hi, Tinswalo. You can put your hand up and we can... Chifaro, no, there's no father graph. There's no father graph. Tinswalo, what's up, my sweetie? No, Karabo, they're not. Okay. But that's the beauty of the mother graph. Okay. And I'm going to explain. Yes, Palesa. No worries, Tika lady, welcome.
Hey, ma'am.
Okay,
Hello,
Palesa, can I mute you for 1 second and speak to Tinswalo and then I'll unmute you. Okay. Hi, Tinswalo. Tinswalo, are you there?
Hello, ma'am.
Hello? Oh, no. Okay, Tinswalo's not speaking. Tinswalo, can you type your question in the chat for me, please? Palesa, what's up?
I wanted to ask a question. I started getting lost by the 180 degrees. I did not see where did you get.
Okay, so I chose that we're going to put 180 degrees on our calculator. But because we're doing the sine graph, my sweetie, we're going to be replacing all the x values with these numbers, 90, 180, 270, and 360. So all you need to do, Palisa, is go into your calculator and type in sine of, start with 90, and then it will give you 1. So you're going to go to 90 and 1, and you're going to make a point. Okay. Then you're going to go to sine of 180. And you'll see that sine of 180, how much does it give you on your calculator?
It gives me 0.
Good. So do you see how I put the mark for 180 where y is equal to 0?
Yes.
Okay, good. Go to your calculator, put in sine of 270.
It's -1.
Good. Do you see how I've put 270? I've joined 270 and -1 there.
Yes.
And then sine of 360. What do you think that one's going to give us?
0.
Good. Now I've joined all of those dots that we've just drawn with a curved line. You see that?
Yes. Thank you.
You're very welcome, my sweetie. All right. Excellent stuff. Tinswalo, are you still there? Okay. We're going to give Tinswalo a second. Let's talk about the cos graph, guys. Let's talk about the cos graph. We're going to do the same thing, guys. That's 1, -1.
Hey, ma'am.
0. Hello, my sweetie.
I just wanted to ask if all
the mother graph start from 90 degrees to 360, or is
Okay,
it
the
just
sine,
this one?
the sine and the cos graph will start from 0 to 360, but the tan graph will start from 0 to 180. Okay. All right,
Okay,
but I'm
thank
going to
you.
explain, I'm going to explain why. Okay.
Thank you, ma'am.
All right. You're very welcome, my sweetie. Rimofile, what's up? Okay, let's start again, guys. Okay.
No, ma'am,
Hello.
it's fine.
Okay. All right, my sweetie. No worries, Aisha. I know it happens. All right. Not Dinzola Rimofile. Please remember to mute for me, my sweetie. Okay, guys, we're going to do the same exercise again. Okay. Except this time we're going to start with cos of 0. Pop in the chat. What is cos of 0? Ooh, Karabo, it's not 0. Ooh, it's not 0. Punch it into your calculator. What is cos of 0? Cos of 0 is 1. Good. Cos of 0 is 1. So our cos graph is not going to start here where 0 degrees is 0. It's not. Our cos graph is going to start at 1. Okay. What about cos of 90? Yes, absolutely. You should be drawing. You should be drawing, Pelisa. Cos of 90 is 0. Now we get to 0. Good. Cos of 90 is 0. So at 90 and 0, we make a point. What about cos of 180, guys? Cos of 180, -1. Good. You just need to punch it into your calculator, guys. Nothing fancy. Cos of 180 will give us -1. Cos of 270, 0. Good. Remember to stay muted, guys. All right. And then cos of 360. Punch in cos of 360 for me. It will equal 1. Good. Right. And we're just going to match 360 with 1. Hi, Tabang. What's up?
Let's say like if we get like, would we get a test like this? Like if we were to get a test, were we supposed
Yes.
to? We would have to draw like a whole graph like this, huh?
Yep, absolutely. Okay. But Tabang, do you notice how ma'am is using the same points over and over and over again?
Yes, sir.
Right? I'm using 0 degrees, 90 degrees, 180, 270, and 360.
Yes, sir.
Right? So if they ever said to you, Tabang, draw the graph of cos anything, you are going to use these points. You're going to use 0, 90, 180, 270, 360. Do you see how I'm just increasing by 90 every time?
Yes, sir.
Yeah. So if they ask you to sketch the graph of this function, you just put those points into your calculator and you're going to get an answer. Okay.
Okay, ma'am. Thank you, ma'am.
Excellent. Very, very good question, because now Tabang has taken away the answer, the question that I was going to ask earlier. Okay. Somebody named iPhone is saying, I didn't get how the graph started from 1 and not 0. Punch into your calculator cos of 0. Punch into your calculator cos of 0 and tell us what it gives us. Swela, what's up, my sweetie?
Hi, ma'am.
Hello, my sweetie.
Is it possible if for the sine and cos graph, is it possible for them to give us from -360 to +360?
Swela, you've gone away, my sweetie. What's up?
Ma'am, I was asking, is it possible like for them to give us from -360 to +360?
Absolutely. And then all you do is you do the same thing, Swela, except in the opposite direction. You start at 0, and then in this direction, we minus 90. So you're going to punch into your calculator cos of -90. And then the next one will be cos of -180. And the next one will be cos of negative 270. You're just going to do it in the opposite direction.
So it means
Okay.
we're gonna have 4 Cartesian plates.
That's it. So you'll just extend it. So this is how it will look. It will look like this. And on this side will be the positive numbers like that. And then on this side, you'll have your negative numbers.
Okay, thank you.
That's all. All right, my sweetie. Okay. All right. No, we did do a 360. Did we not do a 360? We did do a 360. Okay. The topic is trig functions. Okay. I see somebody saying, ma'am, you're moving a bit too fast. Can you slow down? You need to tell me where I've left you behind because I'm not going to be able to remember where to go. Okay. Yes, TJ, it's going to be up on our website in a little bit. Okay. Yes, Shaden.
Ma'am, I just wanted to find out on the mother graph, are they always going to give us those 4 angles like 90, 180, 270, and 360? Are we always going to have to write down those 4 angles?
I say use those ones. Okay. The reason I say use those ones is because it's easy to remember 0, 1, 0, minus 1, 0. That's why we use those. Okay. But the mother graph is very important because we're going to start shifting things around. Okay.
Okay, thank you.
All right. Okay. Anutita, what's going on? I see a lot of ma'ams happening in the chat. I need you guys to ask your pointed questions, please. Anutita, what's up?
Hi, ma'am.
Hello, my boy. What's going on?
I just wanted to ask you if you can scroll up. I saw a table showing us how the cos, sine and tan graphs look like. Yes, that's the one. I wanted to look at it again. And I just wanted to question on why the tan graph looks like that.
We're about to get there because we're about to draw the tan mother graph, and I'm going to show you why.
Okay.
Okay.
Thank you
Okay.
very much.
All right. Okay. Watch, guys, because we're gonna do it ourselves, and we're gonna figure out why. Okay, Tabang, do you have another question?
Yes, ma'am. Ma'am, for the
What's up?
cos graph, why did we start with 1?
Because cos of 0 is equal to, punch cos of 0 into your calculator. What is it going to give you?
That's what I didn't do. That's the one that I didn't do. Oh, it's 1.
Cos of 0
Okay.
is 1.
1.
All right.
So, ma'am, every
Excellent.
time.
Oh, sorry. Unmute for me. I cut you off. I'm sorry, my boy. Every time?
Every time they give us a graph that we have to do ourselves, we always have to put either sin cos of 10 equals 0. Do we start with the numbers?
So you always start with sine of 0 or cos of 0 or tan of 0. Okay, we must always start at 0. Okay.
To see where our graph can start.
Because this point over here is 0, 0. So we must start at 0, 0. Okay?
Okay. Yes, ma'am.
Excellent.
Thank you, ma'am.
Oh.
I love this teacher.
Right, Remufilwe, what's up? For those of you who are who know where I'm getting, I want you guys to think of the tan graph. We're going to do the exact same thing, guys. We are going to put in 0. And instead of putting in just 90 this time, I want us to put in 45. Okay. For the tan graph, I want you guys to put in 45 degrees as well. Put in 90 degrees.
Ma'am.
In 135. Yes, Remufilwe. Hi, my sweetie. What's up?
Ma'am, I just wanted to ask that, will I always be given the positive of the degrees, or will I also be given the negative?
You can also be given the negatives, but they're going to be about the same. Okay. It's going to be about the same thing. So if I put in cos of negative 90, I'm also going to get 0. Okay. Try it on your calculator and you'll see. What is cos of negative 90? Okay, Ramofilo, you're breaking up, my sweetie. Okay, we're going to come back to you in just a bit. Okay. All right, we're going to get back to you. Amogelang, what's up?
Hi, ma'am.
Hello, my sweetie.
I wanted to ask if it's possible for the examiner to say f of x is equals to the inverse of 10.
In this kind of graph, no. Okay, and if they do say the inverse of 10, that means they've given you this number and they want you to tell them what degrees it is. Okay, because if you click the inverse of 10, then it's going to give you the degrees. At the moment, Amogelang, we are putting in the degrees and we're getting the number. If they give you the inverse of 10, then they're giving you the number and they are asking you what degree. Okay. Does that make sense?
Yes.
Good stuff. All right. Akona, what's up, my sweetie?
Ma'am. Hi, ma'am.
Yes. Hello, my sweetie.
Hi. Is this the introduction to the straight line, parabola, and exponential graphs?
Okay, we've already done straight line, parabola, exponential, hyperbola. We've already done them. Okay, and the videos for those lessons are on our website. So they're underneath this lesson that we have right now. Okay, so if you go on the app or on the website, look underneath, you'll see all of the lessons named straight line graph or parabola or those kinds of things. Okay, quadratic function, exponential function, hyperbolic function, they're all there. Okay.
Okay. Thank you, ma'am.
You're very welcome, sweetie. All right. Kara was saying, are we still going to do geometry? We've already done geometry, my boy. Kama, I'm going to come back to your question. I just want to take to you answering the question. I just want to take all of these questions. Okay. Takane, what's up?
So, ma'am, like when they give us this, they won't be giving us like the quadrant angles. So they'll be changing the angles numbers.
Okay, so basically what this is, Takane, is normally we would draw, if we were to draw the quadrants, we would draw it like this and we'd say quadrant 1, quadrant 2, quadrant 3, quadrant 4. Yes?
Yes, ma'am.
So ma'am is splitting it into the quadrants, except instead of doing it in a circular form, I'm doing it in a straight line form. Do you see that? Because over here, this is 90 degrees, this is 180, this is 270, and this is back at 360 again. Do you see how ma'am is doing? I'm doing the same thing, except instead of the quadrants, I've split it up into, I've drawn it in a line.
Yes, ma'am.
Okay, that's what we're doing. We're doing the same thing, but in a line. Okay. Excellent question. Very nice question. Sibahle, what's up? Yes, Aisha, it's supposed to be. Yes.
I wanted to ask, so since when it's 90 degrees, it says undefined. So
yes.
that means you put the dotted line. Same as 180, if I'm not mistaken. So that divide the graph into three parts.
Yes.
So the middle one will actually be it will be the top and the bottom, and then the first one, the top, and the last one will be at the bottom.
That's it. That's it. Okay, because it splits the graph into 3. Okay, but we'll talk about it just now. All right. We're going to get there, Sibahle. Don't stress. We're going to get there. Princess?
Hello, ma'am. Can you hear me?
Yes, I can.
Ma'am, I wanted to ask, you said that like we should put 10 of 90 degrees, right? When I did that, my calculator gave me...
It gave you a math error. It gave you a math error. Yes, sweetie. I know. Okay. If everybody has a question about 10 of 90 and 10 of 180, I need you guys to just pause for me because I'm getting there. I'm getting there. Okay. We're going to explain why that is. You're supposed to get an error, guys. It's not something mind-blowing. You're supposed to get an error. Okay, and we're going to talk about why you get an error. Okay, Hama, do you want to finish this up for me, please, my sweetie? Okay, we're going to run out of
Yes,
time.
girl, I am here for you. I am here for you.
Absolutely. Go for it.
So, the one that I have has been extended to -90, if you don't mind.
Okay. Hold on. Give me 1 second. And whoever said that is correct, because this thing needs to go to 270, sorry. Okay, sure. It starts at -90. So here's what the thing I don't want to do is I don't want to confuse other people. Okay.
Yeah, no,
so
completely understandable.
I want you, can I ask you to start it at 0 for me? Okay. Just so we kind of keep it uniform. Okay.
So, ma'am, so tan of 0 degrees, of course, is going to be 0.
Good.
And then tan of 45 degrees is going to be 1.
Good.
Then after that, you're going to have an asymptote of 90 degrees, where you're going to say, where you're going to label it and say x is equal to 90 degrees.
Good. An asymptote.
Then
Beautiful.
after that,
Continue.
sorry.
Continue.
Oh, for 135, you're going to have -1 degrees. No, sorry, -1, sorry, my mistake. And then after that, for 180, you're going to have 0. Then for 225, you're going to have +1.
Good. 225 is the one that I forgot. Thank you for reminding me. Wait. 225. 225, yes. Good. We're going to get
+1.
+1.
+1.
Good.
Then you're going to have an asymptote of 270, and you're going to label it and say x is equal to 270 degrees.
Good. Excellent. Good stuff. All right. You did that so beautifully.
Are we going to do domain and range?
We are going to do domain and range.
Are we going to do it now? Because I could also do that.
After I'm done with the graph and I've explained to everybody, yes, we're going to get into domain and range.
Perfect. Thank you so much.
Excellent. Yeah. All right. When I say domain and range, Kama, then you must put your hand back up, because you and me were going to have a conversation. Yes, Ramufilwe.
Ma'am, I just wanted ma'am to please repeat what I asked before, because I had some connection problem.
Okay, what was the question again, my sweetie?
My question was, in the exam, if we were given a question about these graphs, are they gonna give us also the negative side of the degrees, or only the positive side?
They might give you the negative side, okay? But all you're gonna do in that case, Ramofilwe, is instead of putting 90 into your calculator, you're just going to put -90 into your calculator.
Okay.
And instead of 180, just put in -180, okay? And it will help.
Thank you.
All right, my sweetie. Okay, cool. So these are all the mother graphs, guys. This is a mother graph. All right. And for all of you who said that, ma'am, 10 of 90 is giving me undefined, ma'am, 10 of 270 is undefined. What is happening here, ma'am? I don't understand. It's an asymptote. Do we remember asymptotes, guys? When do we normally get an asymptote? When we're dividing by what? When do we get an asymptote? When we are dividing by? Good, Ursula, that's it. We get an asymptote when we're dividing by 0. Now, if we go back to the idea that we started with over here, if we put in tan of 90 degrees, tan of 90 degrees is sitting on this line, and this line is going to be 0, or we're going to have 0 and 1. My tan is going to be, tan is equal to 1/0. That's what I'm going to get. Tan of theta is equal to 1/0. Can I get an answer? Am I going to get an answer for 1/0? Am I going to get an answer for 1/0? No. No, it's going to be undefined. And that's why at tan of 90, you're getting undefined, because it's an asymptote. It's an asymptote. Okay. That is why the mother graph of a tan graph has an asymptote. Same with down here. The reason why we get an asymptote at 270 is because 270 is over here, where I've got 0 and -1. Now, if I had to punch in tan of theta is equal to -1 over 0, I'm going to get undefined because I cannot divide by 0. That is why I have an asymptote at 90 degrees and at 270. Give me a thumbs up as to why, if you understand why your calculator is giving you an error. Give me a thumbs up if you understand why. Good. Excellent. Because this thing over here is 90 degrees, and this thing here at the bottom is 270 degrees. This one over here is 180 degrees, and this one is 0. At tan of 90, I'm going to go y value over x value. My y value is 1. My x value is 0. I'm going to get an undefined function. Okay. All right. Now look at the mother graphs, guys. Don't let go of them. Do not let go of the mother graphs. Takane, what's up?
Oh, ma'am, on our last graph, I wanted to know like the last number. I can't see nicely.
It's 270. Sorry, my sweetie, it's 270.
Okay, thank you, ma'am.
All right. Let me write it better. Okay. Lesego, what's up? Hi, Lesego.
Hi, ma'am.
Hello, my boy. What? No, boy. I'm not.
Boy.
All right. Thanks, my boy. What's up?
Ma'am, the reason I can't understand your explanation about the asymptotes right now is the way you explained it is an asymptote is a line that always approaches but never cuts. So when they
Exactly.
get confusing, a little bit confusing because I don't know who to believe.
Okay, you're cutting out, my boy. Okay. I didn't get you there.
Oh, so I don't know who to believe, ma'am. For like,
okay, what do you mean? What do you mean?
Because my teacher says the asymptote is a line that I'm confused. Is it the line that approaches but never cuts, or is it the line that is always but never cuts?
No. Your teacher is correct. Okay. If you will notice, Lesego, that this green graph that I've drawn over here, you see how I've drawn it very close to the asymptote, but it hasn't crossed my asymptote.
Yeah.
It's not allowed to. That's why instead of continuing the graph on this side, I started another graph on this side. Do you see that?
Yeah, yes, ma'am.
That's because I'm not allowed to touch that purple line. It's an asymptote. I can't touch it. I get close to it, but I'm not allowed to touch it. Okay.
Okay. Thank you.
All right, my boy. Shaden, what's up?
Ma'am, I just wanted to find out what's the period and the, I think it's amplitude.
That you know when you say that, and I was about to talk about that like literally 3 seconds ago. Like after everybody's question, I was gonna answer. I was gonna start doing all of that. Okay.
Oh, okay, thank you.
Okay. Ursula, what's up? If you're gonna ask me a question about something I haven't spoken about yet, I promise I'm going to address it. Yes, Chimera, they're necessary.
Hello,
Hi,
ma'am.
Ursula. Yes.
Hi, ma'am. I wanted to ask why the 10 graph ends at 270 and not 360.
Okay, technically, the tan graph ends up at 180. Okay, the tan graph is only this long, and I'm about to explain why when I talk about the period. Okay.
Okay, ma'am. Thank you.
All right. Buntle?
Hi, ma'am.
Hello, my sweetie.
Ma'am, I'm actually confused because when I put in 180 in my calculator, it's giving me undefined. So I don't understand why by 180 there isn't that asymptote line actually.
Are we sure? Are we sure? Punch in tan 180. It should give you 0.
Oh, sorry, 0.
It's 0, my sweetie. Yeah, it is.
Sorry,
It's 0. No worries, my sweetie. You can unmute if you have another question. I know, Shaden. All right, Kama, are you ready? I need someone to explain the period and the amplitude and the domain and range for me. Yes? Kama, are you there? Oh, no. Okay, Kama, answer me when you've got the chance. Okay, guys, can you just give me a thumbs up? Is everybody still with me? Because Kama isn't able to unmute at the moment, and that's scaring me a little bit. Okay, all right, we'll wait for her, but while we wait for her, we're going to start talking about these things. All right, we're going to talk about the period, the amplitude. We've just spoken about the asymptotes, guys. We've just spoken about them. All right, we've just spoken about them. All right, so we're going to talk about 4 more things. The period, the amplitude, the domain, and the range. Okay, we're going to talk about these things. All right, so you will recall, guys, that we started at 0 all the way to 360. And give me a yes in the chat if you agree with me. If this thing was on a Cartesian plane, I would start at 0 and go all the way around to 360. Yes? Are you guys with me there? Good, good. So the period basically tells me how long does it take to finish my graph? How long to finish my graph? How long does it take to finish the graph? So how long does it take me to go up, to start at 0, go up, come back down, and land at 0 again? So I need to go up, down, then back to 0. We started at 0 degrees, and we went all the way to 360 degrees. Okay, we started at 0, and we ended at 360 degrees. So the period of a mother graph for sine, the period of the graph is 360 degrees. Okay, give me a thumbs up if you understand what I'm saying. How long does it take us to go from 0, up, down, back to 0? It takes us 360 degrees. Okay. All right, so okay, Princess, the period just means how long it takes us to draw the graph. Okay, because I can keep going. Do we all agree? I can add another one inside. I can add another graph. Okay, I can do this. I can add another graph on this side, and then I can keep going. Add another graph, but remember, all the graphs are going to look the same. So my question is, how long does it take us to draw exactly one graph? How long does it take us to draw one graph? 360 degrees. They do look like waves. Yes, Kimutuku, they're supposed to look like waves. Okay, so if I kept drawing these waves, they would all look the same. So how long does it take me to draw exactly one wave? 360 degrees. Right, my amplitude is basically how high. Yes, Kanyisile, it takes 360. Okay, my amplitude means how high. How high from 0. So from here to there, that's my highest point. Do you guys agree with me? My highest point is 1. So the amplitude of my graph is 1. That's the amplitude of my graph. Okay. How high from 0 does my graph go up? 1. So my amplitude is 1. Right. If we had to speak about the domain, do you guys remember? We said that the domain is x values. The domain is our x values. Yes? So in this case, we're going to say that our domain starts at 0 degrees and goes all the way to 360 degrees. That's what our okay. All right, Princess, the amplitude is 1, my sweetie. We have to look at how high does my graph go from 0 to 1. That is my highest point. So my graph is exactly 1 unit high. So my amplitude is 1. Okay. Okay, that's fine. That's fine. We're going to get there. Okay, your teacher's going to get there. Okay, Nkechi, because with the sine graph, we choose, with the trig graphs, we choose how long they need to go. Okay, we choose how long it is that we need to go. So we can say that x is an element of real numbers. We can say that, but what that then means is that my graph keeps going forever and ever and ever. Okay. Siamo, I hope it's making sense. Okay. My range, guys, my range is going to be from that point, my highest point, to my lowest point. So my range, because it's my y values, they sit on my y-axis. I'm going to say y is an element of square brackets because I'm going to include -1 and square brackets because I'm going to include 1. Close. Okay, Eunice, my domain is all my x values. All my x values. Okay, x is an element of real numbers. But normally, guys, in a test or an exam, your teacher won't say this. Your question, like the range or the domain you've been given, will not say x is an element of real numbers. It will say this. Okay. Okay, set of all x values. Thank you. X is an element of all the numbers that we can do. Okay, Sinoguhle, the range is from my lowest point to my highest point. So between -1 and 1. That's why my range looks like this. Okay, now if we think about our domain, guys, my domain is every number. My x value can be any number. It can be 111. It can even be 452 degrees. It won't make a difference. Okay, but when we are looking at these graphs, we can't make you draw a graph for forever. Okay, we can't draw the graph forever. So your teacher will do something like this. They'll say that x is an element of, start your graph at